This video is on the factor theorem. Now I have a function here and it's a quadratic function. I have x squared plus 3x minus 10. Now say for example I wanted to factorize this. Now I know how to factorize quadratics. I need to think of two numbers that multiply to give me minus 10, and when I add them I should get 3. Now those two numbers are 5 and minus 2, so I can write x plus 5 times x minus 2, and this is now factorized. Now also, if I wanted to solve this for, say for example, when this was equal to 0, I would say my solutions are x is equal to minus 5 and x is equal to 2. Now I'd like you to see what happens when I'm trying to substitute x is equal to minus 5 into here. So for example, see what happens when you try and find that, and also try and do this one as well. So pause the video now and then have a go at that. Okay, when I'm working this out, so f of minus 5, I can use this one or this one. I can use either one, it's fine, because these are identical. So let's use the first one. So I'll say minus 5 squared plus 3 times minus 5 and minus 10. So this will give me 25 minus 3 times minus 5. So 3 times minus 5 is minus 15. So minus 15, take away 10. So 25 take away 15 is 10. Take away 10 is 0. Now the next one, for this next one, I'll actually use the bottom one. I can use the top one as well, but maybe that's something you can do. So I'll say 2 plus 5 times, so 2 minus 2 here. Now in this bracket I have 2 plus 5, which is 7. So 7 times 2 minus 2 is 0. So I have 7 times 0, and that's equal to 0. Now I'd like you to think, did you expect these to be 0? So for both of these we got 0. So did we expect these to be 0? And are there any other values I can try here where I will get zeros? Okay. Now I'm going to move on to a cubic function now. So here's a cubic function. And again, if I wanted to factorize this, now this is something that I can't use the same method for that I used when I factorized quadratics. But maybe I can think about when I try different numbers here and see what result I get, and then think about how that's going to help me to factorize this. So I'll try 1, minus 1, 2 and minus 2. I have some more numbers here as well, but I'd like you to try first. So pause the video now and work out f of 1, f of minus 1, f of 2 and f of minus 2. So pause the video now and then work these out. Okay, so let's work them out. So f of 1 is 1 cubed minus 2 times 1 squared minus 9 times 1 and then plus 18. So this is equal to 1 take away 2 take away 9 add 18. This was 18. So 1 take away 2 is minus 1, take away 9 is minus 10, add 18 is 8. Now I'll try the next one. So I have minus 1 cubed take away 2 times minus 1 squared take away 9 times minus 1 and plus 18. So minus 1 cubed is minus 1. So I take away, so 2 times minus 1 squared is just 1. So 2 times 1 is 2, and then I have to take away 2. Take away 2. I have 9 times minus 1 is minus 9, and I have a takeaway here, so it will be plus 9. Plus 9. And I have plus 18. So minus 2 take away 2 is minus 3. Add 9 is 6. Add 18 is 24. Okay. Now let's try the next one. So when I substitute 2 cubed minus 2 times 2 squared take away 9 times 2 plus 18. So 2 cubed is 8. Take away 2 squared is 4. 2 times 4 is 8. Then I have take away 9 times 2 is 18. And I have add 18. Now I can see that this is going to give me 8 take away 8, which is 0. And then I have minus 18, add 18, which is 0. So this is going to give me 0. So I have 0 here, and I want you to think about what this means. So when we had, so I tried f of 2, and that gave me 0. Now here, when I tried f of minus 5, I got 0. But then I knew that x plus 5 was a factor of my expression. Also, when I tried 2, I knew x minus 2 was a factor of my expression. So I've tried 2 in my cubic function and I got 0. So this must mean that x minus 2 is a factor. Okay, is a factor of this cubic expression here. Now I'm going to carry on and work these ones out. So let's try this one. So I have minus 2 cubed, take away 2 times minus 2 squared, take away 9 times minus 2 plus 18. So minus 2 cubed is minus 8. Then I have minus 2 squared is 4, 2 times 4 is, or minus 2 times 4 is minus 8. Then I have minus 9 times minus 2, that's plus 18. And I have another plus 18. Okay, so I have minus 8, take away 8 is minus 16. Add 18 is 2, add 18 is 20. So this one is 20. Now you can see that I'm actually looking for 0. So when I have 0, I can say that something is a factor. So let's try this one. 3 cubed minus 2 times 3 squared minus 9 times 3 plus 18. 3 cubed is 27. So minus 2 times 3 squared, that's going to be minus 18. Minus 9 times 3 is minus 27. And I have plus 18. Okay, so I have 27 and minus 27, that's going to give me 0. Minus 18 and 18, that's going to give me 0. So this is 0 as well. So that must mean that, so I tried f of 3. So that must mean x minus 3. So x minus 3 is a factor. X minus 3 is a factor. So now I have 2 factors for my cubic expression. So I have 2 factors for this cubic expression. So I need one more. So let's try this one. So we have minus 3 cubed, take away 2 times minus 3 squared minus 9 times minus 3 and plus 18. So minus 3 cubed is minus 27, and so I have minus 2 times minus 3 squared, so that will be minus 2 times 9, which is minus 18. Minus 9 times minus 3 is plus 27, and then I have add 18 here. So again here I can see that minus 27 and 27 give me 0, minus 18 and 18 give me 0, so this is equal to 0. So this is equal to 0, and that must mean, because I tried f of minus 3, that must mean x plus 3 must be a factor. So x plus 3 is a factor. So now I have 3 factors here. So I have one here, x minus 2, I have x minus 3 is a factor, and x plus 3 is a factor. So I can write my expression again. So I had, so this can be written as x minus 2 x times x minus 3 and times x plus 3. Actually, you might want to multiply this out and see if we actually get this. Okay, but this is what we found. Now also an extra question you can do, you can try and work out, so if f of x is equal to 0, solve for x. So solve this, solve for x. So think about how that's going to work as well. So what we've done is we've used the factor theorem actually to find the factors, of our polynomial expression. So this is the cubic expression here, and we've written this as a product of factors, and these are also a product of linear factors. So all of these are linear, there's no quadratics in my brackets. Okay, so I've written it as a product of linear factors. Now here's what the factor theorem is. So if f of a, so any number in a, gives me 0, then x minus a is a factor of fx, and this is what we've used to factorize this expression here, this cubic expression here. Now here are some questions for you to try. So have a go at these questions. So you need to use the factor theorem for this. Now this is a very important question. How can you tell that the factorization below is wrong? So I have x cubed plus 4x squared plus x minus 6, and I'm saying this is x minus 2 times x plus 2 times x minus 3. How can you tell that this is wrong? Okay, you might have lots of reasons, and I'd like you to write all of these reasons down, and then I'd like you to factorize this expression here completely. Okay, so completely would mean write it as a product of linear factors. We don't want any quadratics. So answer those questions and bring them to the lesson.